So this learning target is GCF and LCM. So first we're going to take a look at the definition of each term. GCF stands for greatest common factor, and it's a number or variable that goes into two or more terms evenly. So we're going to be initially looking at the greatest common factor of numbers, but we are going to expand that to look at variables as well. So an example with just numbers, 12 and 28, the GCF is 4, because 4 divides into 12 evenly, and 4 divides into 28 evenly. There are no numbers that are bigger than that, so that's where the greatest comes from, that goes into both numbers. LCM is least common multiple, and that is the smallest least value that two or more terms go into evenly. So now the terms we're given are the factors of the least common multiple. So an example would be 4 and 10. The least common multiple is 20 because 4 goes into 20 evenly and 10 goes into 20 evenly. So notice when we're looking for a greatest common factor, the GCF is smaller than the two numbers we're given. When we're looking for a least common multiple, that is greater than the two numbers we are given. And I should say greater than or equal to, and same with GCF, less than or equal to. Alright, so as I mentioned, learning target 3, GCF and LCM. Hopefully by the end of the day tomorrow in class you can say, I can determine the GCF and LCM of two terms containing numbers and variables. So that might be the new information for you. I'm sure you've seen GCF and LCM before. So quickly we're going to take a look at how to find GCF of numbers, and we can use factor trees. If the numbers are small enough, like 15 and 27, you may be able to just run through the list of factors that you know and pick out the greatest one. But as the numbers get larger, it's nice to have a process. So we'll go through our process, which is factor trees, as I mentioned. So 15 is 3 times 5, and 27 is 3 times 9, 9 is 3 times 3. So when you're finding the GCF, you circle the numbers that are in common in both lists. So in this case, each factor tree has a 3. The fact that there are extra 3s in the 27 factor tree we don't use because they're not also in the 15 factor tree. Remember, we're finding a common factor, so we're looking for factors that they share. They share one 3, but they don't share 2 3s. So the GCF would be 3, and you only use one factor tree with the circled numbers to find your GCF. You don't use both factor trees. Next example, we're looking at 32 and 48. So again, we're going to go ahead and list out the factors. 32 is 4 times 8. 4 is 2 times 2. 8 is 2 times 4, and 4 is 2 times 2. For 48, we have 6 times 8. 6 is 2 times 3. 8 again, 2 times 4, and 4 is 2 times 2. So let's circle those numbers that we see in both lists. So I'm seeing, and again, only the prime numbers. So 4 is in common in both lists, so is 8, but we're only going to look at the prime numbers. So we've got 2 times 2 in both lists. I see 2 2's here, and 2 2's here. So we're going to multiply, we're going to look at one factor tree, and I'm going to multiply all of these 2's together to get my GCF. So there's my greatest common factor of 16. Now we're going to take a look at determining GCF using variables. So same thing with the numbers. We use our factor tree. 24 is 4 times 6. 4 is 2 times 2, and 6 is 2 times 3. For 56, hopefully you remember your multiplication charts, that this is 7 times 8. 8 is 2 times 4, 4 is 2 times 2. And I'm going to show you a shortcut with the variables. I'm going to show you the long way first, but then we have a shortcut for figuring out the GCF with variables. So I'm going to start by circling these numbers that my lists have in common. So we've got 2 times 2 in both lists, and I see an extra 2 in each list as well. To find the GCF with the variables, I'm going to take the x squared and I'm going to expand it. Remember, the exponent is repeated multiplication, so x squared is really x times x, and then we have the times y. So over multiplied by our 56, we have x to the 4th, or x times x times x times x, y cubed, or y times y times y, times z. So then I'm going to go ahead and circle the variables I see in common. I see x times x, and I see a y in each list. So my GCF, I'm going to multiply all of my circled things together from one list. So I'm going to go ahead and look at this list right here. And I see 2 times 2 times 2, or 2 cubed, x times x, or x squared, times y, and 2 cubed is 8. 2 times 2 is 4, times 2 is 8. So the shortcut would be to look at the original question. Notice how we have an x squared and an x to the 4th. So the smaller exponent was 2, and that was the exponent that we had on our GCF. Looking at the y's, I have y and y cubed. The smaller exponent was a single y, and that's what we have for our GCF.